Hey everyone, welcome back to another Nielsen Networking video. Let me ask you, are you ready to take your penetration testing skills to the next level? If so, you are in luck because in this video, I'm going to show you the power of Nmap, which in my opinion is the ultimate network scanning tool. That said, this video will be focused specifically on Nmap when used for penetration testing. I give that disclaimer because we have other videos on the channel that offer a more generalized overview of Nmap and its uses, so that may be more your style. If so, check out the link above or just go browse for it in the channel. Now with that out of the way, and to reiterate, the focus of this video will be on Nmap from a pen tester's perspective. Now what does that mean? That means I'm going to take you step by step through the process of using Nmap for initial host discovery all the way through vulnerability identification and exploitation to show you why I believe Nmap is a must-have in any penetration tester's toolkit. So stick around as we explore the various functionalities of Nmap and learn how to utilize them in your testing process. We're going to go from host discovery to advanced port scanning and service enumeration, and we're going to cover it all. Plus, I will show you how to use Nmap's advanced vulnerability testing features and how to take your results and use them with another tool to test any vulnerabilities that we do discover. So let's get to it. All right, and to get started here, I'm going to go ahead and maximize my terminal. I will be using Kali Linux for this video. That said, Nmap is available for almost every major Linux distribution and even Windows. So that's that. I will be using this from the perspective of a pen tester. So remember that. And we're going to be sticking specifically to Nmap's uses in pen testing. I say that because we're not going to go out and do any open source intelligence gathering. You know, I already would have had permission from the network's owner that I'm performing these on. These are going to be performed in my own virtual network, so obviously I do have permission. But in the real world, you would have needed, to get the permission to get everything ready to where you're at the point we are now on the network, and we're going to perform this host discovery. So that said, let's get started with that. All right, and the first thing we need to do is verify the network we're on. So we're going to type in route, hit enter, and you can see right here, this is the network we're on. And this is the default gateway. And to verify that we're on that network, we can look at our IP address by doing an if config and verifying right here that that is the network we're on. So we are on the 10.0.2.0 network. Good enough. And we're going to start off using this scan. And I'll explain what this is as soon as I'm done typing it. And just an FYI, all these commands you'll be shown today are case sensitive, meaning if you do an Nmap lowercase PR, you're not going to get the result you want and you'll be mad at me. So let's not do that. So case sensitive, and we're going to type in our network /24. You could also do a /8 if you wanted to change the class of network you're scanning. I'm going to leave it here because that's what I need for this, the purpose of this video. You could also write this way if you wanted to. But it's simple. I think it's easier just to do a /24. And then what we're going to do is we're going to hit enter. And we're going to let it do its thing. And while it's doing that, I'll explain what's happening. What this does is it goes out and it sends out an ARP broadcast request to each IP address in that range. So 1 through 254. So as you can see, it went through and scanned 256 IP addresses and it found 7 hosts that are up. The reason we do it this way is because we're trying to limit the transmission to only necessary transmissions. We don't want to go out and do a full-blown, TCP discovery. Like, we don't want to do that because that's like shooting off fireworks and going, oh, we're here. So we're going to start off as low pro as we can to get the information of the hosts that are available. We will then take this further, obviously, but we don't need to then broadcast to the whole entire subnet because we know these are the only hosts on the subnet. So why do we need to send out a scan that scans 256 when there's only 7 hosts? So now we can narrow down our search. Hope that makes sense to you. Now that we have the IPs we need, I'm going to go ahead and open up a file here, and I'm just going to call it iplist.txt, and I am going to add the IP addresses that we just discovered. And here we are. I'm going to go ahead and save it and get out of it. Now that we have that, we are good to go. We no longer need to do network discovery on this network. But what if you needed to scan an external website or an external network? You're going to need to use something besides layer 2. So for that, we're going to use a layer 3 scan. And here's how we're going to do it. We're going to first use sudo, if I selected the active screen, and we're going to do a -pe-sn, and I'm going to scan a website that is actually hosted by Nmap. This is a free site they put up that they allow the general public to go and run Nmap scans against it. So you can practice your techniques on this website. Pretty cool that they do that. So we're going to go ahead and run this. And I guess I should put in the actual command because that wouldn't have worked. So we're going to go ahead and do that. And we're going to go ahead and hit enter. And our results came in really quick. And it's looking like, okay, the scan went through successfully. We know there is a host there. We know the IP is this. And that is all we cared about. We wanted to verify that there was a host there using layer 3, and we did. And since we didn't use ARP, you may be curious about what we used, and we actually sent an ICMP echo request out there. And that came back and let us know that there was a device out there. Now, if we would have done this against a bigger network, it would have taken a lot longer because ARP is really quick compared to these ICMP echo requests. So just an FYI, if you're going out there and you are doing this against a bigger network and it's not returning as quickly as you would expect, that's why. It's totally expected behavior. So that's that. Now let's say that didn't work. The reason likely is going to be because the firewall is in your way and it's saying, no, I'm blocking those requests. So you're like, dang it, what do I do now? Well, now we're going to go and try layer 4. And how we would try layer 4 is as follows. First thing, we'll clean this up. And then we're going to want to go and nmap-pa 80 to port 80. And we're going to do sn again. And we're going to do scanme.nmap.org once again. And we're going to hit enter. And we got what looks like the same results as the layer 3. And it is the same results. I mean, it's not warning us about using ICMP that we need root. But nevertheless, we got the same. We got the IP address and we got that it is up. Now, it doesn't look a lot different to you, but it is. And what's happening is we're actually using layer 4. We sent acknowledgement packets to the host. And as a result, the live host responded with a TCP RST reset packet, indicating that we have received the packet and there is no open communication channel. That means the host is up. So if this were a firewall, this would have gone through and at least showed us that the host is up on this IP range. And that's what we wanted to accomplish. So now that we know how to do that, we're going to go back to what we discovered in our layer 2 scanning using ARP, which is my internal network, using my internal devices. So let's get started on those. I'm going to go ahead and clean this up and we'll get to it. All right, and real quick, before we get to port scanning, we need to understand what we're going to be looking for. And specifically, we're going to be looking for the port state. We want to see the results come back that the port is open. This is good. This means that it's accepting connections, whether it's TCP, UDP, or SCTP. Obviously, we're going to be looking for the first two. If it comes back as closed, not good. That means it's closed, and other than verifying that there is a device at that IP address, there's not much else we're going to be able to do at this point with Nmap. Filtered, this is a very vague response, doesn't help us out that much. I'm not going to waste time explaining it. Feel free to screenshot this or pause the video and check all these out with more detail if you want. Unfiltered, this means it's accessible, but it can't tell if it's open or closed. Not the most helpful, but it does suggest that you go and scan, maybe using a different technique. Maybe you use a layer 4 or layer 2 or layer 3, whatever you initiated with, try a different method and see if you can get a little further. Open filtered, similar, but it's unable, Nmap was unable to determine if the port was even active. So a little less useful than unfiltered. Last one, closed filtered, pretty much means it's closed. So the ones we're really going to look for are open and unfiltered. The other ones we're just going to kind of like, not really worth the time. So that said, now we're going to move into the port scanning. All right, we're going to start with the most basic of all Nmap scans, and that is going to be Nmap and then the IP address of the device you want to scan. Hit enter and boom, just like that, your first scan is done. Now, what did this do? This scan scans the first 1,000 most commonly used TCP ports and then returns the results. So it scanned them against my Kali Linux box that I'm on right now, and they all return that they are closed. That's good. I didn't expect them to be open, but that is how you could do it. Now, let's say you wanted to do this to the entire network. You could do that, but instead of doing that, you would do this. But again, remember what we did in the beginning. We did host discovery so we could stay low pro, under the radar. We don't want to, shoot up fireworks again. We want to stay under the radar as long as possible. So what we're going to do, we're going to go ahead and use our IP list and tell Nmap to use that. So just to review what's in here, those are the IPs we're going to scan. And to tell Nmap to scan those, I simply do this. And then I give it the name of the list. So it's going to be nmap-il IP list. And we hit enter and wait for the results. All right, and the results are in, so let's take a look. It's going to start up top. It's going to go, I believe it's going to start with the lowest IP, and as it gets higher, go down that way. So it started with my Kali Linux box, which we already know has nothing very fun to look at. Going down the line here, we have another machine on 2.7. That looks like it has a lot of stuff we'll look into further. Keep continuing down here. 2.9 has some stuff we'll look into. 2.13, 14, and 254 has at least port 80. So all the other devices look to have something we can investigate a little bit further. So let's go ahead and move on to the next scan we could look into. All right, and this next scan is going to be useful if you are looking for specific ports. So let's say we were looking to see what devices had SSH open. So what you would do is you would go Nmap, you would do a -p, and then you would put in, what port are we looking for? Let's say 22. So then we would put in -il to point to our IP list, and we would put iplist.txt. Hit enter and wait for the results. And that came really quick. So what it's telling us is it's closed here, it's filtered here, it's open here. So 2.13 is open. Closed, 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 and it looks like it's closed on all the other IP addresses. But we do know now we could investigate SSH on this one. So see, that can be useful. Let's say you wanted to do the same thing, but you wanted to do it for port, let's say 80. See how many of them are running web servers. You can see it right away. Open, open, open. Right off the bat, 3. And then we get closed, and then we're open again. That's unbelievable. So right there, port 80 is almost open on all of them. So you can see how you can do that. And you could even combine it. Let's say you wanted to do 80 and you wanted to do, let's just say 21. Let's see. And it would go through and you could combine them. So you could continue to chain these along. Let's say you also wanted to know if 23 were open. You have to wait a little bit longer. The more you put, the longer it's going to take to get the results, obviously, because it's doing more. Makes sense, right? So you go through here and look at this. This one has FTP is open and HTTP is open. Let's see if any of them, oh, look at this guy right here. All 3 are open. So that would be a prime target. So that said, that is how you run with a specific or specific ports. All right, we're going to shift gears here a little bit and we're going to go out and we're going to scan for filtered ports. And I know you're thinking, well, why would we want filtered ports? We want filtered ports because we're looking to see if the ports happen to be there and they're just being blocked by firewalls or other devices. And by looking for these filtered devices, we'll know other ports we want to investigate further using different scanning techniques. So to look for these filtered ports, we're going to go ahead and do the following. We're going to do Nmap as normal, and we're going to do a -s and an uppercase A. And then I'm going to tell it to use my IP list. Again, you could tell it to use your specific IP or a range, all that good stuff. And I'm just going to stick with this, and we're going to go ahead and run it. And it's going to warn you, you need root. So what you're going to need to do is either, su to root or use sudo. Oops, you're not going to use su because, or sud's not going to work. We need sudo. So we're going to go ahead and hit enter and let it do its thing. All right, and the results are in. Let's take a quick look here. We'll go from the bottom up this time. So it's looking like 254 is not having anything. But right here, look at this. These are showing us unfiltered. And remember, unfiltered doesn't mean that it's open, but it means it's accessible. So that means we'd want to further investigate that and see if we could get in on port 21 and 80. So let's continue up. None here. None here. So it looks like everything else reported as either showed open in our other scan or it's closed. So this would be the only server we'd want to further investigate on port 21 and 80. Okay, let's try something else here. All right, I think it's about time we look at some UDP ports because we have completely overlooked those until now. And believe it or not, that happens more than you would believe. But you're not going to let that happen because you're going to be thorough. And to do this, we're going to go with an Nmap, like we do with all our commands. And we're going to go sudo nmap, I should have said. And we are then going to put in a -s and a u for UDP. And then we're going to go ahead and put in our il for our IP list. And we're going to let it run. All right, the results are in. Let's go ahead and take a look here. It looks like this first server is showing us that it has some open/filtered. So that's not going to be super useful, so we won't spend too much time looking at that. This is showing that it has a closed UDP port, so that's not super helpful. I'm assuming TCP is open on port 80. That's why it's showing us that. And then this has a combination of, it looks like DNS right here is open. So that's something we would look into. And then it has some open filtered and just some more open. So that's definitely something we'd want to look in on 2.13. And moving up the ladder here, we have more and more open on the next machine up. And it just kind of keeps going with more and more open all the way up. So you can see scanning for UDP was definitely useful, because if we didn't do this scan, we would have been in the dark about some of these other ports that are open that we could have investigated. So let's go ahead and check something else out. All right, for the next step, we want to take this a little bit further now. We've found some open ports, both UDP and TCP, but now we want to know exactly what services and version are running on those ports. So to do this, we need to switch it up a little bit. We're going to need to go with Nmap again. We're going to go sudo, just in case we need it. And we are going to do a -s and a v for version. And then I'm going to do, again, my IP list. You could do, again, the range or the specific IP. And I'm going to go with this. Oops. We'll go ahead and hit enter, and we'll wait for the results here after I put in my password. All right, and the results are in. So let's take a look here. First thing we'll look at is 2.254, which apparently is a Ubuntu server. And we knew port 80 was open on it, but we didn't know what was on it. And apparently it's Apache, and it's running this version of Apache. So you can see how powerful this is. Now we could go out on Google and just look up vulnerabilities for Apache 2.4.52 on Linux. Going up the ladder, we could do the same thing for the next server. But this one is also running an FTP version here, VSFTP 3.0.3. So again, we could go out and see if there's any vulnerabilities for that version of that FTP. And up here, this thing has, you could almost just blind throw something at it and hit a target here. I mean, this is a lot of real estate to deal with here. MySQL, I mean, SSH, my gosh, there's a lot there. So that's definitely one we would be targeting. Going up the ladder again, we have another machine on 2.9 that looks like it has a few things. Looks like it's running SMB and some other things here. So that's another one we'd look into further. And continuing up, look at this. This has a ton of them as well, including IIS, FTP, you name it. It also looks like it's running SMB. So the only one that looks good is the Kali Linux machine I'm on now. So that is how you could look for services and versions running. And that's going to be our kind of our bread and butter for what we're looking for. But now let's say we wanted to know, just to verify, it says Ubuntu here, but how can we take that a level further? And for that, we're going to use this next scan. All right, so following up with that service and version number, we want to know the operating system. And to do that, we are going to do an nmap-o. Pretty basic, right? And then you would just do, you know by now what we're doing. We're not doing that. We're doing this. We're just making sure you were paying attention. Go ahead and hit enter. Actually, we need to sudo this. I caught myself that time. And hit enter and go ahead and wait for the results. And those results are in. So let's mix it up and go from the top down this time. Started with my Kali Linux box, and no surprise here, it did not give it much information. That's what I would hope for. Continuing down here, we have 2.7, which if we continue all the way down to the bottom, we can see that it identified it as a Windows 7 machine, and that is correct. It is running a Windows 7. Continuing down, 2.9 is running Windows XP, and that is also correct. Continuing down, we have 2.13 that is running Linux. It doesn't tell us the exact release or distribution of Linux, but it gives us close enough. We know it's Linux. 2.14 is also Linux. It's saying unreliable, and there are options we can do, or switches we could put on to the command I just ran to get these results that we can look into later. But for now, we don't need that. We don't care so much. We just want to know that it's Linux. And continuing down, our last box is also Linux. So that's 3 Linux boxes and 2 Windows machines. So pretty good there. Well, 4 because Kali Linux, but 3 that were open and returned results. So that's good. Now let's move on to another little technique we can do to either speed up or slow down our scanning. And that technique is pretty easy. I'm going to do it using the most basic of Nmap scans, which is Nmap, and I'm going to do scanme.nmap.org. So we'll run it again, nmap.org. And here's where we're going to put in the switch that's going to control the speed. It's going to be a -T. And the -T has a range from 0 to 5. 0 being slow, what they call paranoid. 5 being the fastest, what they call insane. 3 is the default. 3 is the same as running the scan like this. So to test this, let's go ahead and put a T here, and let's run it at a 5, and we'll see what it says. All right, and the scan finished, and it took 14.15 seconds. So let's go ahead and do that same scan, but let's try running it at a T3. And we'll let it run. All right, and here we go. So this one took almost double. The interesting thing is this actually picked up an extra port that this one didn't. And it's supposed to not work that way. The faster you go, the less accurate your scans are supposed to be. That was going to be my next point of why you would even want to do this. And that goes into the quicker it's going, the less accurate it's going to be, the slower it goes, the more likely you're going to be able to go under the radar, under the intrusion detection systems and things like that. But be warned, when I say slower, I mean considerably slower. I once tried to do this and I used 0, and it was at like 45 minutes for 5 hosts, and I hadn't had a single result, and I just canceled it because it was too long. So just FYI, this is a way to do it, but I would, if you're going to do it, it should be for single host. Do not run this against an entire network, or you're going to be there all day long using a 0. Now, using a 5, it wouldn't take as long, but you're going to set off every alert in the system. So, FYI. So with that said, let's go ahead and move on. All right, and continuing with the theme of trying to stay under the radar, we want to avoid detection, we're going to run what's known as a decoy scan. And this is pretty cool. So what we're going to do is first you need to be root. So we're going to go sudo, or you could, su to root, whatever floats your boat. And then you're going to put in the IP or the subnet of the devices you want to scan. I'm just going to go against Windows 7 here because we haven't picked on Windows 7 enough yet. And then what you would do is you would do a -D, and then you would do RND : and the number of decoy IPs you want to do. I'll go with 20. Let's go crazy. So we're going to go ahead and run this. Oh, before we do that, why don't we do this? Why don't we open Wireshark, and you can see what's going on as it's going on. So let's put these two side by side. If we can pull this off, we should be able to. All right. Let's go ahead and open ETH0, and let's go ahead and run it and see what we get. And boom. As you can see, the outgoing 2.7 is getting flooded by all these source IPs. So now, while we're not completely off the log, we are now in the log with 20 other IP addresses, which will make it a lot harder to pick out one specific IP address. Pretty cool stuff, right? Now over on our end, we got the results we wanted, and we don't notice much difference. This is more going to be for the destination side. You're not going to really get any different, you're not going to get any different results at all. But that's good because we weren't trying to get different results. We just didn't want them to know where we were. So mission accomplished, right? Right on. So let's go ahead and move on to another way to try to avoid detection. All right, the next technique I'm going to show you is how to randomize the order that your scan is performed. By default, if you were to pick a subnet, it's going to start sequentially and work its way through. And that can be pretty easy for, intrusion detection systems and other defensive controls to pick up because you're going from one host to another. This is going to go from A to D to C to F and all over instead of going A, B, C, D, E. So how to do that? Pretty simple. We're going to go Nmap, and we're just going to go IL, and we will go ahead and put in IP list.txt. And at the end, all you need to do is add randomized hosts. And I believe we need to be root for this, so we're going to throw a sudo in there, and we'll go ahead and hit enter. And now we'll wait and see what happens. All right, and the scan completed. Let's go up and take a look. This should go from 2 to 7 to 9. And as you can see, it went from 4, to 9 to 13 to 7 and down to 14, and ended up with 254. So as you can see, it did exactly what we asked it to. So that's another technique to keep you off the radar. All right, and the second to last technique I want to show you to try to avoid detection is going to be how to spoof your MAC address. And this is pretty straightforward. We're just going to go sudo nmap, then enter the IP address of the device you want to scan. I'll go ahead and run this against our Kali Linux box here just to see what we get. And then what we're going to do is we're going to go spoof MAC, and then you'll enter a 0 to randomize the number. If you wanted to actually fill it in, you could go ahead and do that as well, but I don't really see what the point of that would be. So I'm going to go ahead and run this and see what we get. And as you can see, here's what it went with. That's the MAC it picked for us, scanned, and we knew this box had no open ports because it's pretty well hearted. So what we want to do now is check to verify that it didn't really use our real MAC. And here's our real MAC, so no, it did not. So Pretty straightforward technique. Nevertheless, it can help keep you off some detections if they were, actually blocking MAC addresses instead of IP addresses, because unfortunately there's no easy way to spoof your IP address short of using something called IP change, which uses a proxy, and it's out of the scope of this video. Maybe I'll do another video at some time on that, but that's a little more technical. But nevertheless, this is one more technique. Moving on to the last technique for avoiding detection. For the last technique I want to show you on trying to avoid detection, we're going to do something known as packet fragmentation. And what is that? That is going to be where we're going to take our packets and fragment them into smaller packets. And the reason we do this is we're hoping the smaller packets will be able to avoid detection. They'll be able to, bypass those content filters, firewalls, intrusion detection systems, and things of that nature. So let's go ahead and do it. And to do it, it's very basic. We're going to go nmap or sudo nmap, always sudo. And then we're going to put in the IP address. We'll go against 9 because we picked almost every other server we have here. And then what we're going to do is we're just going to put a -f at the end. That's it. But before we do it, let's go ahead and open up Wireshark so we can take a look at what it looks like going out. So we'll do that. Go ahead and do that. And let's go ahead and hit enter. Done. Go over here. And this looks normal, right? But check it out. Oops, scroll by it so fast. See this? This is a fragment that was broken up. And all these all the way up here. And you can see it goes all the way up there. So in my personal experience, I would say this helps maybe 1 out of every 5 times. This isn't like this is going to work every time. It's going to get by the detection systems. It's not all that great, but you know what? It is another tool, and it's definitely worth keeping in your arsenal. So that said, let's move on to testing these services for vulnerabilities. All right, at this point, if this were a penetration test, let's see what we've done. We've discovered the devices on the network. We have singled out the devices we want. We have singled out what ports were open on them, what services were running on those ports, what versions of services were running, and what operating system. So we have compiled all this data. Now at this point, we're ready to go to the next level. And what we're going to do at that stage is we're going to now test to see if there's any known vulnerabilities to those specific service versions running on each of those hosts. And to do that, we're going to leverage Nmap scripting. And to get scripts, you can either go out to their website. Right here, I'll show you. You're just going to go to nmap.org. I'll put the whole URL in the description. And here you're going to get a listing of scripts, a really long listing of scripts of all different kinds of built-in scripts that you can either download by clicking on them and hitting download. Some of these are actually already pre-built in, and some of these actually come with different distributions of Linux. But if for whatever reason it's not, you could always go here and download them. So that will work for everyone, Windows, Linux, you name it, you can go here and get them. So for those of you on Kali Linux, you're in luck because they actually come pre-installed or pre-loaded, I should say. And to get there, you would just go to this location and actually one more folder in here. So if we do this, you can see, well, actually, it's just, maybe this will give you a little bit better view, but you can see they're all here for the most part. Again, if one wasn't here, you could go up and get it from the website. So that's where we're going to get the scripts. Now let's move forward and show you some of the most popular ones to look for vulnerabilities. All right, and before we get to our first script, I'm just going to ask out of the kindness of your heart, if you could smash that like button if you are enjoying this video or learning anything, I would greatly appreciate it. If you want to one-up me on that, go ahead and subscribe for future content. We're trying to get a lot of content out there, and believe it or not, about 80% of our viewers don't subscribe. So they never get the notifications again, and maybe they never come back to see all the great content I believe I'm putting out there. So that out of the way, the first script we're going to run is one that's going to go out and look for SMB vulnerabilities on our 2 Windows machines, which we have an XP and a Windows 7. So enough chit chat, let's get to it. We're going to go ahead and run this command out here. We're going to need to change it up a little bit to add what we want to scan. So I am, of course, going to put in il ip list.txt. This is a little overkill. This is going to scan all devices, but you know what? I don't care if it runs against the Linux machines. We'll at least get the Windows devices while it's scanning that. So that's cool. You would probably want to be specific in each device, but for this video, I'm just going to run this list because, to be honest, it's been a long video. So we're going to let it run and we're going to see what we get. So let's scroll up here. Let's go all the way up to the top. And we can see we got some hits there. So obviously the Linux box, nothing. This is our Windows 7 machine. So scrolling down here we go. Right here is the vulnerability we were looking for, and it's showing it is vulnerable. So that is one we would then, and maybe we'll do it at the end of the video, we would then, go and take it a step further and maybe open Metasploit and see if we could actually exploit that vulnerability. Scrolling down, same thing on our Windows XP machine. So we found those two vulnerabilities. Let's go ahead and check a different vulnerability. All right, next, we're gonna go ahead and scan for a known vulnerability with VSFTP, which we saw at the beginning. Remember how I said I think there's a vulnerability out there? Let's go ahead and find out if there actually is. So again, we're gonna go ahead and paste this in. We're gonna change this, and we're gonna add, our IP list, and we're gonna go ahead and run it. See what we get. All right, and here we are, it's done, and we can see right here, we have one, and of course it's lucky number 13. Surprise, surprise. I thought we'd actually get 2 hits because I remember we saw this twice, but apparently that other version is not vulnerable, but this version is. So 13 is vulnerable to a backdoor here. So that's that. Let's do one more. And for the last script I want to show you, we're going to use a script known as VULN. And what VULN does is it actually scans for all the known vulnerabilities in that category. So instead of individually scanning for, FTP or SMB or SSH known vulnerabilities, it's going to scan for all of them at once. So this would probably be the easiest if you wanted to scan a broad range of vulnerabilities and not a specific one. And to do that, it's really easy. We're going to go Nmap, and we're going to do IL for our list. And then you're just going to do script, and you're going to type in VULN, short for vulnerability. Hit enter and give it a little while, and we'll check the results. All right, and the results are in, and it took a little under 6 minutes. So let's scroll up and look at all what we got. And starting at the top with our Windows 7 machine, scrolling down, you can see it started at the typical ports, worked down, and it looks like the first thing it discovered is a vulnerability with Poodle. This is going to allow for a man-in-the-middle attack, I believe. Yeah, so it found that. Scrolling down, it does tell you that there was no cross-site scripting vulnerabilities found or cross-site request forgeries. So, this doesn't have to just be used by pen testers. This can also be run by net admins, system administrators, to go out there and see what is on your network. Why wait for a pen tester to come in and tell you? You could do this on your own. And if you're doing it from that angle, you can also check out these websites that will give you remediation techniques to use if you wanted to go out and do it that way. So just remember, this isn't just for pen testing. The focus of this video is on pen testing, but this can be used in multiple different ways. So continue on down. It looks like it's also vulnerable to this vulnerability right here, remote desktop protocol, and continuing down, lots of vulnerabilities. So let's continue down here to our next machine here. This is going to be the SMB vulnerability. And wow, okay, so lots on that machine. That is not a pretty machine. And then we're going down here, and I believe this is our Windows XP machine. And this one was vulnerable again right here. Another SMB vulnerability. And I'm just going to kind of continue on down here because we will be here all day. Again, this is that FTP vulnerability we saw. This is another vulnerability with the SSL version they're running. And continue on down. There's lots of vulnerabilities in these machines. And a lot of that is by design. Obviously, for this video, I did put machines out there that were going to give us some results. Otherwise, how would we know what to look for? So, as you can see, we can continue on all day long. There's a lot of vulnerabilities to go through here. So that all said, I think that kind of wraps up the video from Nmap perspective. Now, let's say we wanted to take this one step further, right? Let's say we wanted to actually see if now we could exploit one of the vulnerabilities we discovered. So as a little bit of a bonus here, I'm going to show you how we could see if that's possible using Metasploit. So let's get to that. All right, and if you don't know what Metasploit is, go ahead and check out the 2 videos I have in my Kali Linux security tool series, where I cover the first half of Metasploit, which is the initial exploitation phase, how to use it, how to use all the modules and all the great stuff inside it. And then I cover the post-exploitation, how to set up persistence and things like that. So anyways, I'm going to open up one of the many interfaces of Metasploit. And this interface I'm going to use is called MSF console. Again, really long video here, so forgive me if I sound like I'm rambling here. So we're going to do MSF console, and we're going to go ahead and let it open up after I give it my password. And it shouldn't take too long. And then we're going to get a bunch of text. And here we are. So at this point, what we're going to do, we are going to search for a vulnerability. And I thought I had it copied, but apparently not. So I'm going to copy it right now. We're going to search for a vulnerability with that FTP that we saw earlier on that Linux machine. So what we do is we search for VSFTP. Here we go. We got a hit. It says it's an excellent. That means it should work, hopefully. And what I'm going to do is I'm going to hit use 0. And then I'm going to set my rhost to the IP of that machine, which is 13. And at this point, all we have to do is hit run. And we're going to have to wait here for a second. And it looked like it denied us. Apparently, it didn't want to be nice there. So we're going to do it again because we are persistent. Actually, we'll do persistence later in another video. Actually, check out that second video on post-exploitation for that. So at this point, it looks like it actually worked. I don't know why we had a little hiccup on the first run, but we're good on the second one. And I can prove that by going, who am I? I'm root. Okay, well, you knew I was root probably logging in here because I did sudo, right? But watch this. I'm root on this server. And I can prove that. I can go here, and there I am. Well, that didn't quite work, did it? And there you go. You can see I am not on my Kali Linux box. I am on the Metasploitable server, which is ironic because we're using Metasploit to hack a Metasploitable box. So anyways, you can see that was pretty easy to accomplish, right? So we're about to close it up, but before we do, I mentioned some things you could do for, defensive measures as a system administrator, but just to give you some key advice here, and these are things as a pen tester you would want to offer in that report that you're going to now do, that you've now proven that you could exploit those vulnerabilities. Some things you're going to suggest, they need to keep their servers patched, and that's not just the server itself. They need to keep the applications and services running on those servers patched. They need to get rid of servers that are past end of life. Windows 7, Windows XP, why are they on here? They need to check their logs. They need to have good backups. They need to shut off unneeded ports and services. They need to harden those machines. And they need to be aware of what is out there. Sign up for security feeds, all that great stuff. So I hope you enjoyed this video. If you did, again, I would greatly appreciate a like, subscribe to the channel for future content. And that's all I have. I'm done. That's all I can handle now. So you have a great rest of your day. Talk to you later.